know. Okay, I hope everyone online can hear now. Sorry. All right. What's it about? What did you do? You did. So we'd just like to say a big thanks to Rod Jackson and Rod Ware for all the efforts they've been doing in education. So we've got a little bit of a thank you gift and just wanted to show our appreciation. So up you come, both Rods, please.
Sorry, I'll do it. Right. Thanks, guys. Pleasure.
Big round of applause to the guys. Okay, so just for some of the back of house things. So our current bank balance, obviously the new memberships have just come through. If you haven't had a chance to renew your membership, please do. But we're currently sitting just shy of 180k in the bank at the moment. And just a brief update on what's happening with the new standards coming out for the fire hydrant installations. So I think it's expected to come out the 1st of September, so do look out for that. And also 5601 is coming out in 2022. Don't know what that means. This is Nick that's put this together, by the way. So we haven't got any dodgy photo awards, but Nick's keen to keep this going. So if you do come across any installations we aren't about or anything funny, do feel free to send that on. So we've just shot a couple of little interim pieces in there at the moment, but that one on the right hand side, that's actually a pub near Warren Smith's offices. Okay, that's the general meeting closed, so it's pretty quick. How are we doing for time? Time is it? 10 to 7, okay. So we had a chat this afternoon about strategy, and one of the things that came out of that was obviously a lot of initiatives, but a lot of people come and sit in the same places or come and sit in sort of, with the same people. So we're going to try something. I haven't got what I needed to have, but we're going to get, obviously, who's here for the first time? There's a few people here, yeah. So let's get everybody on their feet. Everyone, on your feet. Okay. What I want you to do is go and talk to someone for about a minute, 2 minutes, and give them, obviously your name, where you're from, but a fun fact. A fun fact. We're going to do that a few times, and it's all about meeting someone you don't know, someone you've not spoken to before, okay? So I'll give you a little do-do-do-do, and it'll change again, okay? We'll do that a couple of times, all right? So go. Okay, 10 seconds, we're going to switch. Okay, move, go somewhere else, talk to someone else you've not spoken to before. Fun facts. Let's see some movement, come on. Okay, we're going to do this one more time. We're going to switch. Fun fact. I want to see everybody moving. Bob, on your feet. Bob. Okay. Everyone back to their seats, please. Wrap it up. Wrap it up. Sorry. Back to your seats, please. Take your seats. Thumbs on seats, please. Wrap it up. Okay. How did everyone find that? Good? Not good? Awkward? Do it again. Is that good? Thumbs up, thumbs down, thumbs up? Yeah? Yeah, and we were talking earlier about, like I said before, everyone sits in the same seats or talks to the same people, but it's all about networking too. And there's obviously a lot of new people here too, so it's fun. And we were trying to sort of encourage that, so I hope you liked it. We'll try and do it again. Every time I see that smile. Okay, that's the general meeting closed, so we're going to crack on. So I'd like to introduce Kate Jennings from Apple, who's going to do a presentation. So welcome, Kate. Big round of applause for Kate, please.
Oh, hi everybody. It's strange to be back in this kind of environment again. It's been a long time. So today, what I wanted to talk to you about was the passive grease traps draft standard. So this is out for public comment at the moment. So it's only out until Friday. So you're on a bit of a timeline now to get reading that standard. Now, my intent today isn't to tell you everything you need to know about the standard. I just wanted to draw your attention to a few of the main things that are in there. And of course, we can have a conversation about this as well, but I can't gather your comments and put them into the public comment. So I guess I just wanted to encourage you all to have a read of it and submit your comments. Okay, so before I dive into the new standard, I'll just give you a little bit of a brief history of time on grease traps in Australia. So the kind of existing standard, AS 4494, that's been around since like the late 90s. It's a really, really short standard, and essentially it just gives the power to the water authority to regulate the trade waste. So it doesn't give any guidance to manufacturers on the design or the performance requirements or the installation of grease traps. So there's been a little bit of a hole there. So I guess to supplement that standard, WASA did have a far more detailed appraisal process for manufacturers to assess their grease traps against. That was disbanded, ran for quite a long time, but it was disbanded in about 2011 and it wasn't replaced. So it meant that then the onus got put onto the water authority to assess grease traps and see that they met their requirements. So what that meant for the industry was that every water authority had a different set of requirements, and I guess makes it harder for you guys to keep on top of what you need. So yeah, all of this in terms of like the design, but also the sizing methodology too. This has just created quite a fragmented industry where essentially just each authority kind of does their own thing. Sydney Water, though, they are a major leader in this area, and smaller authorities like ICON tend to look to Sydney Water for some advice, I guess just piggyback off their approvals list. So yeah, with the sizing, grease traps, sizing up grease traps, that's been one of the most fragmented things in the industry for designers, with each authority doing it differently. There have been a few attempts over the years to kind of harmonise the sizing, and most recently was a guide that WASA published in 2018, but I don't think that's actually really been adopted by any major authorities, so it's largely unaffected the industry. So that's where we've been, but back to the draft standard now. So this has been, we've been working on this for about 3 years. Collectively, and it's finally came out to public comment a couple of months ago. I think Emily shared a link with it to you, and perhaps share another one maybe this week or tomorrow, so you've all got the link to have a look at it. And really this standard is a guide for manufacturers to develop products that are going to work in the Australian market. Generally, there's not massive changes from what's already being done, and just some kind of general sensible advice or some parameters on how the grease trap needs to be designed to positively influence performance. And I'll talk more about that in a sec. Now, one thing to note is that there's no lab test in the standard for assessing the performance of tanks. So there's nothing to benchmark a particular product's performance against another's. There is a section on in situ testing, but because each application is so different, so like the type of food, the size of the restaurant, the size of the trap, the heat of the wastewater, and so on and so forth, it doesn't really give you any understanding of how a trap's going to perform relative to another one. So I think this could be an area of development personally for this standard kind of moving forwards. Now, I think the main challenge, I'm sort of guessing, but I think for you guys is that the sizing, and that this standard now includes a sizing methodology. Again, it'd be up to each water authority about whether they accept this and what comes out in public comment, of course, but it could potentially be quite a big change. So I wanted to talk about that today. Okay, so I'll start with the easy stuff, and this is just some of the product design requirements that the standard has outlined. So they're just logical things like specifying a 70mm distance between the inlet and the outlet. That's been like that forever and a day. Also specifying vent locations relative to the water level, so there's no backup. And it's really just covering off the best practice design for traps that we're already used to seeing in the market. Now, because this isn't a performance-based standard with a lab test, there are some performance-based design requirements brought into that standard that just helped to separate fat soils and grease from wastewater. And that's things like needing at least a 10% air gap above the water level to promote cooling and better separation. So I think looking at this draft standard, you can expect to see very minor changes to the products that you already see in the market, so nothing major. Now on to installation. I just picked out a few things, again, I think kind of most relevant to you guys. So the standard at the moment, the draft standard says that the maximum depth for the traps can be installed from finished floor level to the base of the trap is 3 meters. Now, I think for some applications, this could be a little bit shallow. We know that trucks can pump out up to about 8 meters. That's probably a bit too much for servicing, so perhaps the sweet spot's somewhere in the middle. Another installation query that's come up over the years, time and time again, is clarity on the amount of clearance that you need above a grease trap. So the standard asks for the same depth of the trap to be above it, but it does allow for 1 meter when you can't achieve that. So that was kind of an unwritten rule, but it's good that this has kind of been put in print now as well. I was reading through the draft, the comments today, and one thing that a lot of people have commented on so far is about spill containment. So for above ground traps, the draft standard wants some like bunding, I guess, to contain any spills. But there's a lot of comments on that because it's not really seen that much in the market. Now, in terms of servicing the trap, the standard says that the trap needs to be emptied at least once every 13 weeks, but it does also give other service frequencies. So in the event that your trap's undersized, you can increase the frequency, so an underperforming trap can hopefully be made performing without having to take it out and put a new one in. So onto the sizing. The first part's really easy. This is based on maximum flow rates to meet a retention time of 20 minutes. And that 20 minutes is just is generally what's understood as being the optimum time to separate fat oils and grease from wastewater. So for example, a 3,000 litre trap would have a maximum flow rate of 2.5 litres per second. So in addition to these maximum flow rates is a sizing methodology. So this uses the fixture sizing, the fixture unit sizing from AS 3500 to give a value to common fixtures. Now, I know that data is a bit out of date, and I think that might be updated in the next plumbing code maybe as well. So that I know the chairman's aware of that as a possible issue kind of going forwards, but the standard would be adjusted to suit that. So once you've worked out the number of fixture units that you've got, you then look at the graph, which gives you a peak flow rate. So for example, if we had a 15 fixture units, this would equate to 1.5 litres per second. Now, in instances where AS 3500 is missing a particular fixture that you might need for your application, you can just take the flow rate from the manufacturer of that particular item and convert it into a 20-minute flow rate. So just look at that same example I used before. So we take our 1.5 litres per second flow that we just worked out on the graph, and then multiply it by 1200 to give us the 20-minute flow rate. If we know that we've got an additional flow from an unlisted fixture unit at 0.5 litres per second, we'd also multiply that by 1200 to give us the total size that's required. So in this case, that comes out at 2400 litres. So we'd likely just need to size up to 3,000 litres to be a more commonly used size. Now, if you've got no idea what's going to be going on inside that commercial kitchen, you can just size up the trap based on the maximum capacity of the inlet drainage. I was chatting to Rod earlier, and I know you had a concern, perhaps you'll talk about that, that this might vastly overinflate the size of the trap that's required. What would be quite interesting is to have a look to better understand the sizing that's been proposed, would be to use a live example of a project or one you've recently done. So we can compare current Sydney water sizing with the 2 or even the 3 sizing methods proposed in the standard. So if anybody has got a project that you're working on that you think is suitable just to have a quick look at, please do let me know. I'd just love to run some numbers with you and see how that kind of compares. So public comment, the standard, it came out probably 6 weeks ago or so, but it does close this coming Friday, so you haven't got long to read this. And I know it's probably going to be top of the pile of your bedtime reading, I'm sure, to get through this week. But yeah, your comments at this stage really do make the standard better. So if you have got time and you're interested in it, please do have a read. It's really easy to submit your comments now. As you read through, you can just submit them as you go, so it doesn't actually take you that long. Yeah, and then once this public comment period's closed, the committee will review all of those comments, integrate them hopefully, and then publish the standard. So I imagine that it'll be published probably early next year. And there's normally about a 9-month grace period for standards for both manufacturers and designers to kind of start using them and get to know the standard. And of course, once it's live, HCAA will share some information that's been published as well. So I just want to open the floor to questions or comments and discussions with each other as well. If anybody has anything they want to chat about. I might not be able to answer it, but somebody else might.
Any questions?
So your thing is passive grease traps.
Yeah.
Is an active grease trap a DAF unit? What's the definition of what passive mean?
Passive is just no biological or mechanical means to aid grease separation. So no skimmers, no DAF, no dosing.
I thought you worked for ACO.
Yeah.
And are you on the standards committee for the grease trap?
Yeah, we sell grease traps too.
Well, I didn't know that.
I'll talk to our marketing team.
Should also greet Kevin Quizzy. Kevin hasn't been here for about a decade, so he's a special guest. So everybody give Kevin a clap, please. Thank you very much.
Anybody got any other questions for Kate? Here you go, Tommy. It's going to be highly technical.
I know, so I'm nervous.
That was great, thanks, Kate. Hey, I was wondering, on the outlet of grease arresters, did the committee talk about potential to install reflux valves to stop any surcharge getting into a grease arrestor and maybe just creating more of a pain to clean out?
Yeah, there is a section in there on reflux valves. I just can't really remember what it says. And I'm also with the committee stuff, I can't talk about what happened or why things happened or what was discussed. It's all committee in confidence.
Yeah.
So that's why I can't give you any padding to this. I can just give you the facts, I suppose. I don't know.
Read the draft.
There's time yet till Friday.
Thanks, Kate.
No worries.
Any other questions?
Kate, did the committee talk about the sizing of the grease arresters? Because every state, for South Australia, we have different sizes. We have 2,400 to 5,000.
Yeah.
In between. So why does everyone have different sizes in each state?
I think that's just historical as to why there's different capacities. But I think the only thing that sort of dictate there's no standard nominal sizes in the standard. It does call up common industry sizes: 1,000, 1,500, 2,000, 3,000, 4,000, 5,000. That's it. But I guess anything outside of that's also okay too. If there's a particular capacity, like the 2,400 litre, for example, that you want to have.
I'm going to just go first. That's got a couple of okay, and what this be?
With the sizing, is there an allowance there for cleaning it more regularly than not?
Yeah, so with, and this was the point somebody made to me earlier, is that this might need to be just clarified, but with existing grease traps, if it's underperforming, you can increase the service frequency. So from 13 weeks, you can make it 6 weeks so that the trap can perform properly. But I think that was an important addition so that you're not taking grease traps out.
Give me the last shit.
Okay, probably just answer the question, Joel here from Howden, about sizes in other states. Well, that's because of localised manufacturing. So a lot of companies, say in South Australia, did have a 2,400 litre mould, so they just multi-purposed it. But Kate, the question for you, what did the standard cover as far as venting or pre-treatment devices?
What, in terms of the installation?
Yes, venting requirements.
I think this was just on the inlet and outlet that we needed to vent them, and you couldn't share the vent. That's not something, I have to say, it's not something I'm particularly across, but it's there should you want to read it in the standard.
The new standard allows you to interconnect to decrease together. Doesn't say what sizing criteria. Again, Howard from Howden. The new standard, or the draft standard, I must say, says that you can connect grease arrestor vents with another grease arrestor vent. It doesn't say how many grease arrestors you can connect. It doesn't say what size you need to make that vent. I do know that Dave Stablina from Stantec, Tom Wise from Warren Smith and Partners, and myself and Representative Sydney Water, James Milton in particular over there, have been working a long time with this joining events together. And I can't really say, but I think Sydney Water will have some information at some stage about allowing vents to be joined together. And that will probably come out maybe before this standard does indeed come out. And I think you'll be surprised that there could be a number of up to maybe seven. Maybe can't say too much, James. Sydney Water is looking at a
there are any requirements for combined chamber vents. I'm not 100% sure what the exact requirements are, but at this stage, it's just in draft. It's with our engineering area, and I'm sure that we'll be releasing something soon to the industry. So that's going to be a city water requirement. And I guess the basis behind it is a lot of properties now getting retrofitted where they've needed larger grease traps and more, grease arrestor areas. So we've got an existing building. We can't run a grease arrestor up for every grease arrestor because there's no room. So the combined chambering that was going to make it a lot easier for installers to mix those vents, but you can't mix the vents. They'll only be chamber vents, so you can't mix an inlet with an outlet. Only with the chamber vents will be combined.
Okay. Thank you.
Okay, I'll come to you in a second. There's just a question online for the first time ever. It's from Ryan, not Clown. So Ryan down in Hobart's asking, or stating, it doesn't have anything about grease traps in basements of buildings. Maybe needing transfer pumps. Will that be looked at?
I'm given that we're at the draft standard, I don't think new stuff can be put in. But yeah, I just say note that in your comments. Brian, please.
Then what's he saying here? RVs are in there, but not about an overflow gully on trade baselines.
I'm
you
sorry.
About that?
Sorry, say it again.
Oh, someone else is chipping in now. You just started something. So you said RVs are in there, but there's nothing about an overflow gully on the trade baseline. Is that required?
I don't recall what, but I couldn't talk about it.
Okay,
if I
that's
did.
fine.
I'm
And
sorry.
then Paul McDonald's just chipped in. Is there anything in the new code about reduced size arresters?
Reduced from, but this sort of goes back to the point earlier about increased frequencies. So you can keep with a smaller arrestor but still perform. So maybe that was where that was coming from. Let me know if they ask anything more. Thank you.
Okay, my question wasn't on exactly that, because I'm working on a number of jobs where Sydney Water have come forward and said, no, it's undersized. That hasn't been an option. You need to upgrade your grease arrestor. And I've worked with Howard as well on a particular job where we've been able to go larger than 5,000 litres as well, but we've gone up to 10,000 litres, which the guys at Sydney Water that I spoke to have said they're willing to use this as a bit of a test case anyway. And that's involving interlinking your vents and that as well, because it's an existing centre where it's not really possible to go back in, or you're shutting down a shopping centre to go back in and separate all these drainage lines, which are going to existing grease arresters, to actually take them out and to put 5 or 6 grease arresters where 2 are existing. You'd have to basically shut the shopping centre down and reroute all the drainage again. But it is possible, well, at this point in time, that we can look at larger grease arresters. There are a couple of, and Howard will be able to tell you, there's a couple of larger ones that are 20,000 litres in New South Wales as well. So there are ways around it, but it's a long process to go through all the approvals and that as well. But when I've been dealing with Sydney Water, there's no way that you could just say reduce capacity, increase servicing.
Yeah, and I guess
that's interesting, you know.
Yeah, but I suppose it depends too about whether or not Sydney Water accept this standard and use it, or they maintain their own appraisal. But I guess that's not for me to comment on.
One other thing that isn't discussed at all is upstream arresters. Has it been looked at all?
Like under sink kind of traps, you mean, or?
No, there's a number of upstream arresters which deal with the grease at the point to reduce the big dippers, and there's a number of other appliances that which reduce all the grease upstream to limit what goes downstream.
Yeah, this doesn't cover that. I think from memory the minimum size is about 500 litre capacity, I think, but don't quote me on that.
Yeah, because that's not less than what's currently.
Yeah, a lot smaller than those under sink ones for sure.
Okay.
Yeah,
thanks.
A lot larger. Yeah.
Any more questions? Oh, I see someone else with a hand up. Of course. This way.
Thank you. Just on that, we have been involved in the past in a job where two 5,000s were made to be replaced with a DAF because the shopping centre wasn't performing. And to just reduce the frequency doesn't really get rid of the problem. You've got to think about if the volume of that grease restaurant is sized to allow flow to allow that to cool down. Just because you're cleaning it every 6 weeks instead of 13, you've still got warm waste going through the trap and depositing suspended grease into the sewer, right? So it's a last resort. You don't want that to be your go-to. Look at, I've had a look and made my comments on the standard, but some of the key ones for me that really stood out was, you know, Sydney Water, we look at anything under 30 metres for the length of a drain. You need to start looking at hot water flush, heat trace and insulation and things like that to keep it warm so that it gets to the arrestor. New standard nominates 10, which that's pretty short. There is very few installations anywhere that are going to achieve that. Right. So that means you're getting rid of anything that is just a straight piece of HDPE pipe. That was one. One was the distance that a grease arrestor can be from a habitable building, opening, doorway. It nominates you cannot be near to the building. My comment was that needs to be defined as an actual number, 10 metres, 15 metres, I don't care. Near is just going to be arguments left, right and centre. Okay, so that, you know, you can imagine if you've got a contractor say, oh, I want to put it here, and you go, well, hang on, that's going to sting. It's like, but it's not near the building. How do you justify your argument in that sense if the standard is that vague? Sorry, what was that? Maybe we can produce a HCAA one. It's near enough. Look, the biggest one I wanted to talk about, and which I hope you all do take note of and comment, is the sizing guide, right? I don't know about the rest of you. The majority of jobs that we work on, whether it's a hospital, a shopping centre, you've often got these retail tenancies that are cold shell. You don't know who's going to be in there. You probably have a client that is saying, all right, well, these 3 are not hot food, these 4 are hot food. And the way we size based on the Sydney Water standard is we look at the area of those, we take that 1 square metre per person out of the BCA, and we say, all right, well, that's a 70 square metre tenancy, and we exclude the back of house and kitchen and lounge. Therefore, that's 70 seats, 1,000 litres, I want to say up to 79, maybe 69. So, you know, I find that quite a good solution. The way that the current standard draft is written, there's 2 options really, and one is if you have the fixtures and you know all the fixtures in the tenancy, then you can use those fixtures, calculate the flow rate, determine the size, right? No brainer, that's a good solution. The second option is you can use real data of a flow rate from that source. I don't know how that even got in there. How can you build something, discharge grease into a sewer for whatever time you need to determine a real live data? I'm sure Sydney Water doesn't want grease just pumping into that sewer. And then go, all right, well, it's 3.2 litres a second, therefore we'll put in a 4,000 litre grease arrestor 2 months later. It's not going to happen. You can't have a retrospective sizing of a pre-treatment product.
Probably works from a HCAA or something like that.
Well, that's a good point. If they have a store that's exactly the same size, yeah.
Not be those meters are on the outlet of the grease arrest or whatever the treatment system is anyway.
Yeah.
No, so that's where they're measuring it. So it's not taking a grease arrest out for 3 months or something.
Yeah.
It's on the outlet of the testing.
I hadn't thought of that.
Sorry, the treatment system.
Thank you. Look, the other solution is there is a separate clause that talks about if you don't know what is in your tenancy. And the way it's written, it says, well, you need to, if you're providing a 100mm connection point for that tenancy, you need to allow for the maximum fixed unit loadings in that pipe. So you might have a 70 square metre tenancy and you've got to allow for 165 fixed units. If you look at the calculation in the code, that equals a 5,000 litre grease rester. So you're going to provide a 5,000 litre rester for every 70 square metre tenancy, which is ridiculous. We do not need to do that. I would think Sydney Water would probably agree that is way over the top. So, look, I'm not telling you what to say or do, but I'm just trying to point these out. I've certainly commented on the standard to say this is ridiculous. Please, before Friday, if you get on there and you have a look at the comments that are on there, there are not that many. When it's an Australian project, an Australian-wide resource. If we only get 20 comments saying this is a bad clause, the people that are running this are just going to say, oh, well, it's good because we've got 15 people across the whole country that actually care. If we get 50 or 100 or more, then they'll sit back and think about, well, maybe we need to rewrite that. So please get on there this week. Otherwise, it will be adopted. As soon as it's adopted, if Sydney Water adopts it, you've got to live by it and don't complain later.
Pardon me? Well, all standards are up to you whether or not you use them or not. It's, yeah, I don't think, unless Sydney Water say you have to use an AS 5215 grease trap, then I don't think that it can be pushed. All standards are kind of optional. Paul, Howard.
Okay, we've got one more. We've got a question online. Sorry, Howard, give us a sec. So Paul McDonald is asking, UK. We are on a project where there are 3 500-litre inline grease arresters. Is this addressed in the code, or is this something that Sydney Water or the local authority will need to comment on?
The standard, and forgive me, I've just come back from the UK 2 days ago, so I'm a bit jet lagged. The standard, I think, is only for single grease traps. It doesn't look at connecting grease traps up in series. This is a single chamber. As to whether or not Sydney Water will adopt that, I defer to Sydney Water to comment.
Just again, everybody here, on the standard, there are a number of manufacturers sat on the standard, as well as every water authority in Australia, and like Federation and flying in and out with COVID rules, etc. Every state was different, so are every authority's requirements. Each state had their own push. Again, just like the South Australian firefighters, wanted so much pressure and stuff in their main. So every authority wanted some input into the standard, and I believe. Personally, it's not as a member of any manufacturing organisation, but personally, I think that the standard falls very short of being a document that can be adopted or a working document for anyone in the consulting industry to use. With related to the fixture units, they give you a fixture unit rating for a sink, a basin, and a floor waste. Everything else is up for your guess. Now, who can put their hand up and tell me how much hot water is in a kettle pot? What size kettle pot? How much water in the bain-marie? What temperature is the bain-marie? Cold bain-marie, hot bain-marie? None of those figures are available in the standard. None of those figures are easily obtainable from a manufacturer. So it leaves us very short of being able to say definitively, this is the size grease arrestor we need for any particular project. So that's a big, big hole in the standard. There was a code 2018, which most people have a copy of, and most people I've spoken to, I've sent a copy to. It's got combi ovens down to woks. Now, previous to that, some councils have 3 times the water volume per hour of a wok is to be allowed in the grease arrestor. Was the code has now changed that to 200 litres. But some councils still want 3 times the flow rate. So what is the flow rate to a wok? So does everyone understand a wet wok? They usually just run the laundry tap arm. A laundry tap arm over the wok, and it's running constantly while they're cooking. Most people have a double wok installed. So there was a standard that says 200 litres per wok, so that's 400 litres allowance in your grease arrestor. But, the water tap's running 9 litres per minute for a single or a double wok. I've got restaurants that have got a 1,000 litre greaser restaurant, they've got 6 woks installed. An Asian restaurant, I've calculated the greaser restaurant, there was a code to be 3,500 litres with the fixtures fitting there, and it's got a 1,000 litre greaser restaurant. And that's the sort of information we need to have. We need to have something definitive in the standard. It's not there at this stage. The water code is adopted by basically everyone except Sydney Water within their policy documents. It's usually a direct replication of the WASA code with 1 or 2 minor differences on one particular fitting or another. And that's also adopted in the Department of Planning and Industry code. The WASA code's adopted in that, and that's a signature for everyone in New South Wales Regional Councils adopt that code. So that standard's been out for a long time, and that's a very good sizing. So I think it falls very much short. And with regard to the blank spaces, 1,000 litre per tenancy, if we're talking about Sydney Water, well, you talk to the Tradeways guys and they'll say, well, we want 1,500 litres if it's going to be Asian as a minimum. Asian or some Eastern restaurant. So again, I've spoken to people and said, well, know your locality where you're going to put it. If you're going to put a new tenancy in Chatswood, it's going to be Asian. So leaving 1,000 litre for a grease restaurant is not going to be enough. So it does fall short. And yes, the more comments you all put in, the better. Again, the standard also says you've got to bund every grease arrestor. Do you all know the bunding requirements here for Sydney Water even? You need to bund a grease arrestor in Sydney Water's area if there's a floor waste. If there's no floor waste, you don't have to bund. With a floor waste, 110% bunding, no floor waste, no bunding. So don't put your RPZ, tundish, or floor waste next to your grease arrestor if you're not prepared to bund. So that's not even mentioned. It's just that bunding is required on every grease arrestor. So once you bund, you've got trip hazards, you've got step up to and step down, or ramp up to and ramp down. More space in a spatial for an architect to understand. So it goes on and on and on. So, make your comments, look at it and think about it. What you really need is what you should ask for in the standard.
Thank you very much. Okay, I think we're going to wrap it up there. So let's give a big round of applause to Kate. She didn't have to do that. Thanks, Kate. Well done, Kate. So obviously, Greece is the word. So I did there. So we're going to roll with it. We're going to go straight into to welcome Para to the stage. Now, Para and I had a conversation. I tried to pronounce his last name about 100 times. It does not work for me. So Para's going to announce himself in a second when he comes up here. So let's give a big round of applause to Para.
Thanks, Paul. So I'm actually going to talk a bit about our trade-based requirements. Sort of like starting as in sort of discussions point, probably I guess you all know at least some level. Maybe this will actually clarify if things are differently understood or anything like that. So let me start the night with acknowledging the country. I respectfully pay respect to the traditional owners of this land where we actually live and work. I pay my respect to the elders past, present, and the future. Okay, today I'm going to talk a bit about the difference between the industrial and commercial trade waste. So we have, or perhaps we got deemed process, but mainly what involves is industrial and commercial trade waste. And actually, then I will be talking more into the commercial areas, dive into the retail foods that needs, and a little bit about grease arrestor sizing. Other big area we have in our area of operation is actually motor vehicle industries. And then the third, if I to say, is actually laundry, then give some general requirements for the trade-based agreements. So industrial wastewater. Industrial wastewaters are a bit complex. It's actually vary in quality over the day, over the week. Depends how the operations happens on the site. So that's actually defined as industrial waste. And actually, that means we actually individually tailor the agreement based on the risk the custom poses for us in terms of protection of our assets or the treatment process and environment and so on. I'll go into a bit of a detail about the risk at the end. So actually, there is a very strict or higher level of requirements for the customer to meet with the industrial agreements in terms of ongoing monitoring and actually reporting. And we also have a kind of auditing and audit sampling, and actually also even we have one-on-one discussions with the customer about the performance and progresses. Sydney Water actually, these industrial agreements are actually managed based on the pollution load that's going to be discharged into the Sydney Water, and also that need to meet our acceptance standards. Our acceptance standards are on our website, so the customer must meet the acceptance standard. I mentioned about the risk index. We have actually divide our customers in the risk categories from 1 to 7. 1 means highest risk, and the 7 means the lowest risk. And so the higher the risk, more regular sampling by us, by the customer. There is more regular inspections by us, because they are either high load, higher volume, or potentially actually risky pollutants coming into our system, or they are not very sure about what kind of pollutants they will be receiving. For example, drum washing, I would say, is one of the risky business, or the liquid-based depots, because they will be receiving the waste from different sources. And that could be anything different or anything like that, depends on how they screen the process and so on. So they will be sitting in the highest risk. Then come to the commercial trade wastewater. Majority of our customers, or trade-based customers, are commercial. They are predominantly food-based in the motor vehicle industry, restaurants, function centers, and fast food outlets, to an extent, small-scale food processors. Similarly, motor vehicle industries, mechanical workshops, car wash, service station forecourts, and so on. And the car washes, again, the ones under the 12 kiloliters are treated as a commercial. If it is larger than 12 kiloliters per day, will be categorized as industrial, and they will be issued with the industrial agreement. These commercial the commercial permits are actually issued with the condition they install approved pre-treatment processes. For example, food process will have a grease arresters, and the motor vehicle or motor vehicle industry would be having oil water separators, and laundry would be having a cooling pits and lint arresters. So I'll be going a bit more detail into them. So retail food outlets. Oh, sorry. It's a little bit faster. Okay. retail food industry, our standard requirements is there is a comprehensive plumber guide about our requirements, mainly about plumbing for food industry guide that gives you what is required. The highlights is actually if a premises prepared hot food or serve hot food, even if you prepare the food outside, but if you are serving the food, hot food on premises, you need to have a grease arresters. The grease arresters generally sized based on the seating capacity for the restaurant, but we do use other methods as well. For example, if it is a hotel, the bed size is also taken into account. If the food prepared on site is actually highly greasy, for example, barbecue food preparation place that need a larger size. These informations are available on our guide, so you can get more information on it. Our minimum requirement for the grease arresters are 1,000 liters, 1 kiloliter. For example, the places like the takeaway foods or school canteens and that kind of places where it is difficult to do an assessment. All the food preparing areas, basins and the flow waste need to have a basket arresters. Hand wash basin doesn't need to have one, but all other basins and flow waste does need to have a basket arresters to capture the coarse or larger food particles entering into the system. If there is a bin wash and there is a grease arresters on site, they need to be actually installed with the, so the water flow, water will go to the grease arresters, and there also need to have basket arresters. The next one is about motor vehicle industry. So motor vehicle, again, particularly I'm paying attention to the, so we could have a residential vehicle wash facilities or the commercial. So there are different requirements. The residential facility doesn't need to have any written permit from us, but they need to meet our minimum requirements. That includes it's actually, they need to have in a bonded and roofed area, so no rainwater enter into the city water sewer. The bonding also prevents the wash water entering the stormwater environment. And it's a general requirement, same as the commercial food outlets, that they also do have a basket arresters to capture the coarse solids. There must be a signage because you can't do a mechanical repairs or actually degreasing on the residential facilities. So there must be a signage on the site clearly saying that that should not be done. And there need to be a minimum of 1,000 liter collection tank or 1,000 liter per hour oil water separators. And the pre-treatment must be maintained according to the manufacturer's requirements. Commercial, as I said, the commercial permits only will be given for the car wash facilities less than 12 kiloliters a day. There should be a general purpose pit with a minimum 500 liters of working volume. I want to re-emphasize 500 liters working volume. So generally the pit will be larger than 500 to meet that 500 liters working volume, and minimum of 1,000 liters per hour operating capacity, but that need to be sized. Yeah.
Just a quick one. Why is the commercial car wash got a smaller operating volume of a general purpose pit than a residential? I would have thought it would have had a higher output and a higher load, requiring a bigger volume.
It's actually based on the fact the commercial facilities are regularly operated and maintained, so they can actually managed. But that is one of the point we are actually currently we are reviewing these to standardize all these pit sizes to uniform, but that is at the moment in the review. That might be changed, but that is the current policy. So I'm talking the current policy. So then again, all the pre-treatment products, grease arresters, cooling pits, oil water separators, all need to be from our authorized production list, product list, which is again available on our website. So they need to be selected from that. Commercial laundries. Any laundry that is the commercial laundries that processing less than 2 megaliters a year. Hospitals, boarding houses or nursing homes will be treated as a commercial trade waste. But if it is more than 2 megaliters a day, that will be treated as industrial. So they need to be issued with the industrial agreements. And any laundry, regardless of the size, if they are washing any clothes or the industrial clothes or contaminated clothes that could have a harmful pollutants, will be treated or may be treated as a industrial. So we have to do the assessment about it. The minimum requirements is a cooling pit, because our acceptance standard is actually 38 degrees when it is discharged to the sewer. So cooling pits need to be sized accordingly. And pump pit could be used as a cooling pit, but that need to be sized accordingly so it can, yes.
A lot of these diagrams that you're bringing up,
yeah,
a lot of the consultants that have been around for a long time would have had all these diagrams. They've all been taken off the web for the last 3 or 4 years. And I've rung them up many times saying, you've taken this off, you've taken this off. Why have you taken them off? And they keep on saying, oh, we're working on it, we're working on changing all these things at the moment, but you're bringing up the same old diagrams that we had 3 or 4 years ago. I just don't understand why they've disappeared.
I think the right question should be is the old trade waste standard that City Water had, that had all these diagrams in it. Can we get a copy of it? Or put it back on the web. You know exactly what we're talking about.
So you see the diagrams make it clearer, the words. Is that what you're saying? Yeah. Yeah. That's just a comment.
I'll take that as a comment, and actually we'll look at that. If there is really an interest, I will actually pass that back and find out why is that happened.
You can't find any of this information on the web now. If you go on the web now, you can't find any of this information that was there years ago. And you talk to someone online there and they just, sorry, we're working on changes. So it's like, but this has been going on for 3 or 4 years. It's just like, where are we? And that 38 degrees, well, it used to be 38.5. That's where it hits the sewer. It's not where it goes back into your private sewer. It's where it goes into the board sewer, is my understanding.
Yes, but it need to be at the monitoring point.
at the monitoring board. As it was explained to me many years ago by a Sydney Water inspector, that that monitoring point is where it goes back into the authority sewer. It's not at the outlet of the laundry or whatever that case may be. It's the boundary track. That's right, yeah.
For the general purpose, for the purpose of actually deemed to be compliant, the most convenient monitoring point is where at the outlet of that cooling pit, or because if it is the case of a industrial agreement.
I understand what you're saying,
yeah.
But from a legislative point of view,
yeah.
You know, if this ends up in court somewhere,
yeah.
it's the point that it hits the sewer is what's in the legislation, is it not? Or
it's actually ultimately our aim is to protect our environment, or the health or safety of the people. So there may be a gray area as you suggested.
Yeah.
But for the purpose of practically assessing or actually managing that agreement, that is what, and particularly that is more clearer in the industrial agreement. I have to.
I might add some comments here. I've been in trade waste since 1990, and it's always been 38 degrees centigrade. And we always previously asked for all trade waste to be at a single point so that we could monitor it. And there's always been a debate about, are we concerned with temperature or quality at the connection to our main? And we've utilised that strategy because it's easier for customers to deal with that scenario. So it tends to work with hospitals, like university type facilities, TAFE colleges, where we basically look at the various streams, and we then take it as one discharge point. There was a few other questions about the oil water separators. Now, with the commercial arrangement, it states a minimum of 500 litre collection. Well, you could put in 1,000, you could put 2,000 in. The reality is it goes through an oil water separator, and that's where your separation occurs. Whereas in the residential, you don't have an oil water separator, you just have 1,000 litre pit, and generally you don't have the volume of water, the hydraulic load going through the unit at, in the residential sector. So that's why we state the 1,000 litre for residential. But yeah, I'm happy. Sorry, Parra, I'll let you go.
Yeah, sorry, just on that though, this is an important point, because all this information has been taken off the web.
Yeah.
There's a lot of residentials that I look at now that are still put all water separators and a holding tank.
Yeah.
So I go back there and look at it and say, well, okay, you find you've done something that's commercial, but I'm telling them they only do 500 litre worth of capacity, not 1,000 litres worth of capacity.
For residential?
Residential. Because it's going to go back to this as a whole.
Yeah.
You don't have the information on there.
One of the things that we at Sydney Water, we're not just trade waste. So we have a communications team, and the communications team looks at the messages and what we want to display on our website. And unfortunately, things have been watered down over the years. Just for everyone to know, I've taken over a lead technical role just this week. And one of the things that I'll be trying to do is try to bring back the old commercial pre-treatment booklet and some of the other publications. But it's a battle with the comms people to ensure that we get what we want and it doesn't get taken down, with another comms person saying, but that's not the core business of Sydney Water. The core business is selling water, treating wastewater, and trade waste is just one component of it. So we've got to sort of highlight the importance of your industry and the fact that you do want these sorts of publications. And I think that will be a message that Para and I will, you know, bring back to our management team. So we'll try to get that in place. Another thing that's occurring for those that use tap-in, there is a group working on the tap-in process to try to make it a little bit more user-friendly, because as those who've used Sydney Water tap-in would realise that it can be difficult and it may not give you the information that you require. So there is some work and things that are happening, and hopefully we'll be able to deliver the things that you guys want sooner than the better, actually, on my part, my thinking anyway. Anyway, Para, sorry.
Yeah, with the tap-in, you want to say something?
Just continue, Para. We'll do questions at the end. Keep going.
Thank you. Yeah, on the tap-in front, yeah, actually, particularly there is a more rigorous sort of like guiding through kind of approach what we are working on. So actually step-by-step questions and more detailed questions. So at one go should be able to provide all the information needed. So the commercial permits can be generated easier. That is what we are working on. It's still not finalized. Just I had meeting even yesterday as well on that, but there is improvements coming on the tap-in. So with the commercial laundries, so cooling pits of 1,000 minimum, and then actually again it need to be sized to meet the 38 degrees discharge temperatures. And lint arresters is another unit you need to have it. Nowadays, many laundry units would be coming with the inbuilt one. If that is the case, there doesn't need to be another separate one, but otherwise there need to be a lint arresters as well. General trade-based requirements. As I said, like all the trade-based generating areas need to be funded to prevent the trade-based water entering into the environment or stormwater, or the rainwater entering into the sewer. And there must be a roof with the 10 degrees overhang. So if there is an open sides, that need to have a 10 degrees roof overhang. So that way it's from the bund to the roof line. So that way it doesn't actually prevent the rainwater entering into the system. Other important area is about the chemical storage or chemicals and oils and things like that. They need to be stored in a separately bonded areas, because those pre-treatment devices are not designed to treat large amount of oils or grease or chemicals entered into the trade-based. So that actually become a non-compliant discharge. So for that reason, all the chemicals and oils and things like that need to be separately bonded. And if there is an accidental spills or anything happened, that need to be actually disposed, collected and disposed to both sides. Other two main requirements, if the site is actually a trade-based site, need to have a backflow prevention. High hazard backflow preventions need to be installed. They need to be tested and reported annually to Sydney Water. And actually, there need to be additional backflow prevention devices on the taps where there is a nearby the trade-based generating area. Accessibility of the pre-treatment devices also important. So if they are taller than 1.2 meters, either grease traps or oil water separators, they need to be access platforms confined to the Australian standards. I think that's where sort of like it's a brief note about our trade-based requirements. Happy to answer questions.
Yeah. Okay.
Can't stress enough.
Yeah.
We love having you guys here. We're not trying to Sydney water bash or, have a massive go at it. Look, I kind of reiterate Mark's comments. Having been around for way too long, it's when I first started, I know there was a really amazing set of hard copy documents available. My bosses had them, they shared them with me. I should have photocopied every single one, I didn't. But I do find there is a sort of a dwindling amount of information on the website, and to the point where even I feel like maybe 2 or 3 months ago, if you click on the plumbing and drainage and developing tab, there was a tradeways link. That is even more. So now you've actually got to go to the search function to type in tradeways to get to the the retail food industries and stuff like that. So it does feel like it's getting harder and harder to get that information. Now, we don't really mind what you want. We just need to know what you want. Because the worst thing that we can do as consultants is design something, it goes to tender, it gets priced, it gets quoted. At that point, a trade waste agreement gets submitted by the customer. Sydney Water then goes to have a look at the site and says, oh, hang on, your trade waste pre-treatment's not really up to scratch. We then look stupid, there's a variation for the project, and it all goes wrong. If we have those documents there, all we're after is just, you tell us what you want. We can design for it, it gets quoted, and it all gets installed. So I think that's kind of where we're getting at in terms of we love having those resources available. If you've got them, fantastic. My only other comment, which was sort of touched on earlier in terms of the WOCs, I like the idea of the sizing based on seats. If there's a different scenario where you say, hey, if you have an inkling that this is going to be a WOC heavy installation or a barbecue heavy installation, again, just put it in a guideline. We'll design for it. But it's not there yet. And we don't know about those things. So.
Yeah, hearing that, surely, because as Michael said, that's a battle now we have to take back to our people, because we are loudly hearing that message.
There is a reciprocal absolute points on
That's good to hear.
It's in a way, it's a good life, because repeatedly when we hear that, we can actually, or repeatedly we can tell our people, look, this is what we are finding as a gap. This is why we have this issue. So
I think just echoing what everyone's been saying, one of our committee members requested, is it possible to get a contact detail with the trade waste department? Whether it's yourself or Michael or whoever it is there a way to share your email or phone number? There's always a lot of queries or things that are missing. Is that possible? Or not?
The general, if you call the general Sydney Water number, they can actually connect to us. But anyone actually here, I'm happy to provide my details as well. But ideally, it's easier to get to the Sydney Water general number and connect to. Sure. The other way is actually businesscustomers@sydneywater.com.au is the email address. So that is actually monitored centrally, and I will forward it to the right person to follow it up.
People online that can't hear you.
Copy of the old publication, it's 2.23 megs. If I send it to someone, can you distribute it amongst your people? So it's an electronic copy of the document from 2000. I was a lot skinnier, had more hair in the photos. So it just shows you, but the information is generally relevant, sort of thing. So I'll get an electronic copy. We'll send it to you guys, and then you can share it amongst.
That sounds great. Yeah, good solution. Yeah, well done. Thank you. Okay, Greg.
So I think if your presentation, in one of your earlier slides, you said that if, could you go back again? And again, retail, you said something about cooking food off-site. If food was prepared off-site, but delivered to a site, you needed to put a grease trap in.
Yeah.
I found that ambiguous, and you define it as hot food. So what is the definition of hot food? Is it greater than 38 degrees? But it doesn't tell you in that code what that means. But my brain goes back to Civil Water Prison. So Civil Water Prison has about 2,500 men and about 600 ladies, and they have a central kitchen. So all the food is prepped in the kitchen, and it's called cook chill, and then it's delivered on trolley trucks into the inmate area, and then it's reheated. There is no grease traps in these large 900 bed pods, and I didn't know what you were trying to tell me there in that particular topic. I mean, this is hot food we're having here. You can have a caravan park connected to the sewer in the caravan park, and you go to the shop and bring a hot meal home, and that's cooked elsewhere. So I wanted you to clarify that point, please.
Essentially, the reason behind is actually if you're serving a hot food and that hot food plates and cutleries and things like that are washed on site, that's going to generate the grease. The same way it is actually generating when you're preparing the food. So that's the reason where we are coming with the it needed grease arresters.
Thank you.
Yeah. Question online? This is from Tom McDonald. Hi, Farah. He says, with the lint arresters and cooling pits, are Sydney Water okay if the units themselves cool the discharge through heat reclamation and have their own inbuilt grease arresters?
Say again?
He said, with the lint arresters and cooling pits, are Sydney Water okay if the units themselves cool the discharge through heat reclamation and have their own inbuilt grease arresters? You don't understand, do you?
No.
Oh, so he's talking about reclaiming heat from wastewater, I think. He's trying to cool it down, so using plate heat exchangers, yeah. Is that possible?
I haven't heard of that situation.
Because obviously the heat in the discharge from kitchens and stuff are very, very hot. So it looks like Howard's got an answer to that. Okay.
There is.
Yeah.
So whatever you do with your own wastewater is the client's choice.
Yeah.
So our scale business, for example, the washing machine is being treated.
Yeah.
I guess it's what they are trying to capture or utilize that heat or waste heat to some other purpose. Is that right?
Yeah, it's probably using it to recover heat and like sort of, for preheat for hot water units.
We have actually a standard for reducing the acceptance standard for maximum temperature. There is no such thing as a minimum.
Okay.
So that should be okay.
Okay, that's okay. Paul, that's okay. You got a question?
With the cooling pit calculation, it's sort of often shown in some guidelines, specifically meant. I don't know if it's necessarily in yours, but it can be a bit misleading for a designer because it's just a static calculation. It's not time-based. So a lot of people tend to make the mistake of just calculating for the first hour, which means that the other hours of operation, the discharge is hotter than what you sort of had on that slide. So I think maybe if there is any updates to be done, that should probably be addressed in maybe a comment or a time step calculation that somebody could work through to work out their, cooling pit size based on the actual hours of operation rather than this perceived 1 hour.
Yeah, thanks for that comment. It's actually over the day progress, it's going to be, but then again, there is a cool water going through, and how you operate this facility also going to play. Like if you have a multiple units on site and they all work in tandem, is going to be a problem.
Yeah, that's great. Yeah.
Okay, anyone more questions? Are we good? Awesome. All right, let's give a big round of applause to Para. Thank you, Para.
Thank you.
We'll take a quick break and everyone will eat their food and then we'll start again and Mr. Wise will take us through some more water treatment. Thank you.
Oh, there you go.
I
Hello everyone, we're going to start again. We've got some bottles of wine to give away. Who wants to win a bottle of wine? Oh, one person. Oh, two people. Ooh. Alrighty, my lovely assistant Thomas is going to spin the chamber. What is this thing called?
I don't know if it's barrel or
Barrel.
Go on. Who's gonna?
You.
Oh, me?
Yeah.
I get to pull one out.
What's the number?
171. And not that many people. Oh dear.
Try again,
Won't
Tom.
spin again. Let's go an easy number 3.
Number 3.
Alfie.
Alfie? Hey, Alfie! You want a bottle of wine, mate? Come on up. Congratulations. It sounds like a fix, doesn't it?
Yeah.
It's a true story. All right, I've got 2 more bottles. Go again. I can't see that.
I keep picking big numbers. 71.
71. Is that okay? 71? Stephen Morgan. I don't think he's here, is he? No, he's not here.
Oh, no.
No deal.
Okay.
Do it again.
Let's go number 50.
Number 50 is. This is a setup, isn't it? Michael Corretto. Come on up from Sydney Water, Michael. Come on. Oh no, you probably can't take it, can you? You can't take it, can you? Try again, Tom.
All right. Okay. 35. Who's 35?
35. Oh, I know this guy likes a bottle of wine. Come on, Joel. Joel Brooks from Halgen. Congratulations, Joel.
Yeah, I will do. I will do. Rigging my next number.
Well done, mate. Okay, the last bottle of wine's up for grabs.
Okay, magic, mate.
All right. Are we going to go the same number again? That's a big number. 142, probably not there. 95. Why don't we go?
No, it's going to be low.
Why don't we go 56 then, if we just read it a bit?
Number 56 is.
Nick's
It's Nick
Soda.
Soden online. No. What is this? Do it
I
again.
don't know. What about 19?
Sorry, Nick.
What about 19?
Number 19. It's not supposed to be like this, mate. No, I didn't do it again. It's Sydney Water again.
11.
11.
Brad Ryan.
Brad Ryan from ACO. Brad? Is Brad not here?
Oh, well, Kate Jennings, you'll have to take.
Yeah, come on, you can accept it. Come on, get it over, Johnny. Thank you, well done. What was that?
We got
I
you
think
there.
we 3 bottles of wine. Alrighty, so Tom is going to continue with the discussion on water treatment, but taking it a different way. Oh, I'll just jump the slide.
That's right.
So please welcome Tom Wise.
Yeah. Thanks, everyone. So we'll have a bit of a chat about water hygiene and just a bit of a brush overview, and then we'll touch on UV and some of the things that we might need to consider. I should recognise some bodies and people that I've taken work from. No, I haven't actually referenced all the bits and pieces that I've taken, but these are some good contributors if you're looking and working in this space. I should also say thank you to Annette for attending and Sarani as well. So if you need a microbiologist and a chemical engineer to have a chat to about some of these ideas and processes, they're 2 great people to talk to. So the problem, this slide really describes the problem quite well. Something we can't see and something that's really quite hard to decide exactly how to go about dealing with it. So the one size fits all, does it really work? Does it not? So what is water quality and water hygiene? So water quality is basically the chemistry of the water, what will be contained within the water and the like. And the hygiene is controlling the microbial growth within the water supply, fit for drinking. So there's a few different processes to look at when considering. So what effects water quality has on water hygiene? So the age of water is really important, because the longer it sits there, the more degraded the chlorine or whatever oxidizing agent might be present in the water, and the greater ability that there is to then harbour and grow microorganisms. Hardness is a bit of a problem as well, so it's probably something that's not looked at very often, but scale on pipes and the like caused from hard water makes a nice home for biofilm to establish and assists the hiding places for organisms and the like. So some of the things to sort of think about is managing some of those aspects prior to starting. So what's the benchmark? What can you sort of, what is one indicator? And a plate count is an indicator that can tell you how healthy is your plumbing system or your water supply system, how healthy is the water coming to your building. So it's a good starting point before choosing what sort of equipment you might use to remediate your water quality or hygiene. ASPE putting a fairly good, well, a really good paper together at the moment, guidance on Legionella, and I've picked one of their slides at the moment, which is a great sort of identifier as to what in water causes and adds up to an infection and the like. So their document sort of talks a lot about temperature and the quality of the water chemistry to start with, the piping materials that are conveyed, and also the methods to remediate and manage. So well worth a read when it comes out. So what are some of the key things to consider? So basically, to start with, you really need to clean up the water chemistry, i.e. correct the hardness before starting anywhere. The next one is to remove the organic material. So the organic material is basically the food source for microorganisms. The next part is to provide flushing points. So you can manage aged water and also potentially remediate a bit later down the track. Minimizing pipe sizes and also thinking about storage, manages age and obviously surface area for biofilm to grow on. Introduce a mechanism to kill, which is basically what we'll be talking about. After killing, you might want to consider what you need to mop up. So there might be some removal of organisms that have been disabled. Maintain a broad spectrum oxidizing agent. So that's something like chlorine through your system. So be cautious as to not strip the chlorine out of the water, which is something we'll be talking about. And ensure that you can remediate, so flush and dose at a later date if anything does happen to go wrong, which it does. So it's probably a terrible slide to read, really. So these are some of ASPE's suggested root causes, which basically align with what we've just been talking about. But one of the key things there that they've talked about is pipe sizing. So I guess where we land is there's right, wrong, and there's some things that depend on how right or how wrong you might have been. So PSD overestimation. So the PSD estimation that we do at the moment is based on 1940 data, kindly produced by Hunter, based on a probabilistic theorem, and not necessarily validated of recent on empirical data or anything like that. So we're pretty old, and when we have a look at the differences between flush volumes in toilets, they're massive back in the day compared to what we're looking at nowadays. So you can see from this slide, we start to talk about the surface area, because the bigger the pipes, the greater the surface area. So we could be madly overestimating our pipes. Our friends at Deakin have, this is out of their recently published paper, identified how massively overestimating the Australian standard currently is. So the big red bars are the Australian standard. The blue is the measured, but because of the time grab intervals, there was a correction factor of 1.3 applied. So have a look at the greens with the cross lines. So as you can see, we are measuring massively smaller flows than the huge overestimation that the Australian standard's doing. And that overestimation is to the degree of, 217% to 326% big. This is a bit of data that we grabbed from a hospital. I wish I had a pointer, but up the top there, that 7.25 is that was the designer's original design based on what they said was Australian standards. 4.22 is the DIN. We made some adjustments to the data that we actually gathered to 3.75. Now, that was pretty crudely done based on a count of people who'd come through the door and then a maximum OC based on the BCA. So we're being pretty conservative there. But what I probably want to talk about is the average data there at 1.1 litres per second, and then the peak average at 2.3. So quite low compared to, once again, the Australian standard, and this is a hospital. So pipe sizing. There's an old rule, the old 80-20 rule. 80% of the time you'll only see 20% of the flow. So my big green arrow there sort of identifies 20% of the flow. And so you see that the system probably basically sits within that old rule of thumb. Now on to dosing. So every organism has a susceptibility to UV to a certain degree. These guys produce quite a good document to identify between log 1, log 2, log 3, and so on, the dose rate of UV in millijoules per square centimetre. Looking at this data, it sort of says most bacterium and organisms, anything up to about 30 millijoules per square centimetre, you'll get a fairly good kill rate out of that. There's some pretty tough guys out there like Pseudomonas, which you probably see around 100 millijoules per square centimetre. So I think in selecting a dose rate, there's some really good data to have a look at. So what can go wrong? Chlorine is also susceptible to UV and obviously breaks down at differing doses. This is a really good paper here as well, the links at the top. So these two charts here, the top one is free chlorine. The two lines that I put up here are 100 and 200, and you can sort of see that, and this as well is treated water. So it's basically water coming from a water source. We could call this town's main water. So you can sort of see that you do start to degrade your chlorine once you sort of start to exceed the 100 millijoules per square centimetre sort of mark there. I've given some guidance there out of the paper. 15 to 130 is where they're talking. LP is low pressure, MP is medium pressure, and they're the different styles of waves. So this here compares reverse osmosis water against drinking water. So it's a much better controlled environment with RO. So you can probably get to see a better effect as to how UV affects chlorine in the water supply. Reason why? Because this one has a lot of organics and other materials in there, which obviously will oxidize against the chlorine, therefore reducing the chlorine rate more dramatically than not. So you can see that from a dose up to 200, there's probably little to no effect on chlorine based on a UV dose. So I think that these sort of need to be read in conjunction. So what does all this mean? So this is a dose chart provided by a UV lamp supplier. There's three different lamps or three different doses on this chart. The slower the water supply, the greater the dose. So the longer you're exposed, if you're out in the sun for an hour, compared to 6 hours, you're going to get more burnt over the 6-hour period than the 1-hour period. So exactly the same. Now we come back to the problem that we started talking about, which is oversizing. So I've done some very artistic and liberal extrapolation here. So this is an example, don't rely upon this. Out here is our Australian standard. And it probably isn't a bad selection for a doser. Our dose is along this side, so we're, you know, about 30, so probably, luckily, not too bad. This is our 20% mark, where we start to increase our dose because of our slow flowing water. The biggest problem here is we might end up at low flows, moving out of our safe chlorine range. So of course, stripping the chlorine from the water supply, then not having any oxidizing agent or anything to control organism growth in the rest of the pipework once you've passed your UV doser. This is a pretty bad photo that I chose, but I couldn't find a worse photo. These are 3 UV doses in a row. One is turned off, but let's just pretend that actually maybe a few more are turned off. But let's pretend that this is a standard setup. All 3 of those would have been sized to the maximum PSD. So then we go back and we divide the flow rate by 3, which means that through one of the doses, you've got 1/3 less flow, which means that your UV, your square centimeters per, sorry, your millijoules per square centimeter has gone up fairly exponentially. So if we look back at here and we divide it back by 3, we'd be well outside of our safe chlorine zone. So stripping chlorine from the system, not so good. Maybe a more appropriate method would be to size based on a very, very average flow, you know. So the thought being, you've captured most of the water that's used within the building. Yes, you've got a statistical failure because a few parts of the water has actually got past your UV doser without a dose. But then in the whole picture of things, so long as you're managing your water age as well, you probably haven't seen a great degree of detriment to your system, noting that we're talking about town's main drinking water here. So some things to consider: undertake some testing, like need a benchmark to start from, can't size bits and pieces to remediate water quality without actually knowing where we're starting. Provide devices to reduce organics. So that's really key, like a decent filter, 5-micron filter, 5 microns about the size of a red blood cell, starts to pull out a good degree of organic material and also some of the larger bacteria as well. We've been talking about introducing something to kill, not to the detriment of the system or the actual intent. So that's the be careful of your chlorine, even though we have sort of talked about it is a problem, but not a problem at the same time. Maintain chlorine throughout the system because it's a good way of keeping organism growth down. Manage water age and the surface area of the pipes. So we talked about flushing is a great thing. If you have a read of AS 3666, it does give some reasonably wild guidance on flushing, where it does say that every dead leg should be able to be flushed. Now, to what degree it doesn't suggest, and to what velocity it doesn't suggest that either. But you know, good practice might suggest it over 1.9 meters per second. 1.2 is pretty good if you start to look at some of the DINs and VDIs and the like. And then provide remediation opportunities like flushing points. In some healthcare facilities that we have returned to remediate, the installation of a flushing point saw the plate count drop dramatically in a week, whereas everything else the consultant had been attempting hadn't really dropped the system's plate counts to any avail really, which was fixture flushing, because of course you've got varying velocities throughout the system. You haven't got something very constant, and good practice had left taking takeoffs at the top of the pipe, which meant that it left all the debris in the bottom of the pipe. So, I mean, yeah, one good practice caused another problem. So I hope that was informative. If there's any questions, happy to chat. I think I might have got away scot-free.
Do you have any questions?
Good.
A little bit. That's a very good technical presentation.
Yes.
Thank you, Tom.
Thank you. Oh.
Yeah, Rod's not here. Oh, we've got some questions from the front. Here we go. Make sure it's really technical.
I noticed that there's still quite a big focus on plate counts.
Yeah.
Do you know that anybody's moving now to microbial activity, because that's the sort of thing that you can monitor online?
Online and ongoing, yeah. I haven't seen any of those systems go in to date, but I think that they're a great technology and innovation to move to, because it can give some early warning signs. For instance, one facility that was doing an annual plate count, because that's what their water management plan said, they only suffered any problems with organisms in their water supply once a year. Then they remediated. Then, of course, they came back a year later and found the same problem, remediated, and so on and so on.
And in the interim period, they're exposed to the risk.
Correct,
Yeah.
which goes back to that blank slide, which says we don't know what we don't know, and we can't see what we can't see with the naked eye. And if the water's running out and it looks watery, most people are pretty comfortable that it's good to go.
Sorry, I just have one more question.
Sure, yeah.
As well. So with the water quality, the quality of the water can actually impact on the system integrity as well. And once you start creating things like corrosion and sites for colonisation, you basically a system shot by that stage. So I wondered if you wanted to comment about the water quality and integrity side of things.
Sure. So some of the corrosion erosion that we've witnessed has been heavy metal areas where the heavy metals have actually dropped out of suspension due to some of the oversizing of the pipes, sat at the lower part of the pipe, and actually caused a metal-induced oil. Differing material-induced corrosion, which was quite an interesting phenomenon that, of course, then provides plenty of cracks, crevices, and food as well for more organic activity. Not organic, I mean microbiological activity.
Thank you.
Did I answer that last question okay?
Yeah. Thanks for the presentation.
No, pleasure. Thank you. Yep.
Question. A number of years ago, we had the Western Australian Hospital.
Yes.
It was being built, I think, by Hollands.
Okay.
I can't remember, in Western Australian Health. And they had a 300 diameter ring main around the whole precinct.
Yes. Wow. Geez, that's
and
big.
They drew off water of a 20-metre dead leg end of the 300-metre main to fill all the fire tanks and water tanks.
Yeah.
And they did all their testing on that, and we had breakdown within the system. Have you ever followed that through any further as to?
I haven't. I'm not actually too sure where that landed.
That was an outgrowth within that 300-metre dead main, and that was drawn into the system. Now they had to strip out that whole building.
Yeah.
Every pipe work, every valve had degraded within 12 months. They put stainless steel piping in, and I think that lasted six or 7 months in different areas of the hospital. Anyone remember the report we had here at the AHA's meeting?
Yeah, I remember that.
Yeah, they thought the stainless steel pipe, when they put it in after the copper,
Yeah.
stainless, and they thought the stainless steel was not up to scratch.
Yeah.
And algae growth, so often be very aware of what mains you're drawing off if you get a remote location or the end of a water main.
it's not being regularly used by, upstream users don't use the water, and you're pulling up a dead main at the end. So
I mean, that might have even been, and we're speculating here, obviously, like microbial induced corrosion, which is quite an interesting phenomenon.
the material was lasting. I think it lasted 6 months or even 6 weeks. They saw degradation in stainless steel.
Sure.
Yeah. So every valve was pulled, every thermostatic mixing valve, every isolation valve, they all went to. It's a really important subject.
Yeah, and not knowing that specific project, but then I mean, filters really are, in my mind, key to start with, because they give you a good opportunity to remove organics. Plus, they do start to capture some of the heavier metals and the like that might be about in the water supply.
Two questions. One maybe the answer here is Legionella and this a real risk outside of hospitals? Like, is it a perceived risk, or is it just a risk that we might think might happen? Like, I look at the Sydney water mains and I say to myself, my house is connected to the Sydney water main that doesn't flush out.
Yeah.
Is that a real risk? Should I stop drinking the water in my tap?
I might invite Annette up to deal with
That's the
this.
first question. Second question is, second question is, I've had the opportunity to work with Matt Cox on a couple of projects. You've got all the images, you're showing all the water going through the UV out into the system, but has everyone considered like actually circulating the water back through the tanks, so you don't have that problem with the UV and chlorination? Like, you actually keep the water in the tank clean, so trying to get the water tank dirty and then clean it before it gets into the system.
I guess that's a double-edged sword, because you'll see multiple passes of water across the filter, so you'll actually probably better degrade the chlorine. If we're trying to maintain chlorine, we'd probably be better at degrading it in that sort of system. Yeah, so one method might be reasonable screen filtration to remove organics. Then pass through a very high dose of UV, knowing that you'll strip out a good portion of the chlorine prior to a tank, then reintroduce chlorine at a controlled amount into the tank, and then probably a very low dose, sort of like we're talking about here, just in case anything has grown in the tank, because of course the lids aren't, sealed lids, and there's a lot of surface area in there as well.
And my concern is that you're trying to reduce the flow into the hospital, when the hospitals is normally designed for 100%.
Sure.
But you want to not do it, you said it 20%.
Yeah.
That to me is like a risk.
But then the device will still be able to have the flow pass it, but it just won't be dosed to the same degree. Yeah. A bit like, these charts, if we just think about flow and friction loss, it's a bit the same, more friction loss down the other end, in turn, if we change that to dose, less dose. And that's why you need to clean up, yeah.
Yeah, I was just going to follow up on your question about Legionella. So anywhere where water can stagnate is a potential risk factor for Legionella. So it doesn't matter where it is, whether it's a hospital, whether it's your home. If you've got a second bathroom in your home that's not being used very much, it can actually grow in the shower head. So it's good to be able to, flush things before you actually use them. What we are finding, though, there's a lot of focus now on something called Naegleria fowleri, which is another opportunistic pathogen. It causes primary amoebic meningoencephalitis, and it's nearly always fatal. And what we've seen 1 or 2 examples now where it's being contracted from the distribution system. There was a case, it's normally in recreational waters and it can go up through the nasal cavities and into the brain. But we've seen a case, I think it was in Arizona in the States, where a small child died from what they figured in the end was probably contracted through the distribution system. But Sydney Water's distribution system, as long as it's maintaining, the temperature's good and well built, in a non-risky area, and you're maintaining free chlorine residuals at a decent level, it should be fine. Yeah.
Don't need a job.
I just want to add about UV as well, about the recycling, which is a good idea, but you do have to be mindful of the number of turns, like Tom was saying. And another thing with UV is that it does heat up the water. So depending on the size of the lamp, so if it's an oversized UV, you are going to actually get a negative result, because depending on the lamp, because what happens with UV is that they're really effective when they are not that hot. So we call the gap, which is basically the area between the UV and the water. So which is what the quartz thimble is. So when it gets too hot, it's just like like a normal fluorescent lamp. When it gets hot, it produces less intensity or UV rays. So it becomes less effective with water temperature. So there are, I think they're called amalgamated lamps.
Yeah.
They are more expensive. They can actually
Run a
handle
lot hotter.
higher water temperature. So you have to be mindful of things like that. So it's a good technology, but it's got its limitations. So you have to be aware of it. And as everything, you have to make sure the sizing is accurate. So oversizing anything, like Tom said, is not a solution. So you have to be really mindful of it.
One of the funny things that we did stumble across on a project where they'd used copper welding and hadn't flushed, and also branch formed and drilled out, was the thimbles, and were absolutely filthy. They were as dark as this carpet, where they should be, clear. And this was probably after a month's worth of operation. So it's also making sure that the system has been adequately flushed. And I know that's hard to do as a designer and an engineer when somebody else is doing the job, but you can put belts and braces in and design a perfect system. But if it's not installed in a manner that's hygienic, you end up with the same outcome at the end of the day.
It comes back to validating.
Yes.
Yeah.
Yeah.
And also, like Tom says, some things that a lot of people think of UV as a sterilizer, but it's actually what it also does, oxidize as well. So, for example, depending on the way that you have to find, it's like soluble metals can oxidize. So that's why Tom's saying that you have to be careful, because the oxidation or whatever the oxides would actually end up with the water. So, and then it becomes less.
Yeah.
So it is really important, whatever that you are going to, whatever the application that you're going to do, that the water quality is, it's not one of those systems that, I think it's a term we were talking about that Tom and I, the term used, the common term used is not really accurate.
I think it falls back to this.
Or it's not.
It's got lots of limitations. So it works really well. That's what we talk about dose, UV dose, which is actually got the residence time as a factor as well. So you have to be aware of it. So that's why when Tom showed all those graphs, it's actually the higher the dose, which means it's the intensity plus the amount of time in the UV chamber itself. So things like that, it's a very good science, but the technology wise, I mean, it's a good technology, and the scientific, the way it works is really good,
yeah.
But it has to be used the right way. It's not one of those solutions that just plug it in and it's going to work. It's not.
Yeah. Until they make variable speed driven lamps, it's not it's not there yet.
Yeah, exactly. Something that actually detects the flow rate and the water condition and adapts to it.
Fantastic. Has anyone got any questions? I've got one question, Mike.
Ryan, do you see filters or UV getting written into the code and not just a good to have?
Well, I might answer that question in another way. I heard that fair trading are picking up filtrations and softeners that are required to remediate certain water conditions as performance solutions, which I think is a bit detrimental to public health and the best interest of the public. And when you read the performance requirements, it says, you know, don't contaminate the drinking water supply and keep it fit for the public. So that's a bit of a controversial comment, but I think that fair trading in New South Wales needs to take a better stance as to water hygiene. Will they get written in there? I know that the Australian Building Codes Board about 2 years ago, or 2.5 years ago maybe, were looking at improving the qualifications or the metrics assigned to the water quality performance requirements. And therefore that would then trigger an upgrade or some deemed to satisfy provisions. So in the long term, my answer is yes. But then as exampled by the passive grease arrestor standard, it's difficult to write for every situation because there's so many unknown unknowns, and you really need to design for your specific situation, which is get a water sample. And that really only represents the water that you've grabbed from that single outlet, not necessarily the whole system as well. So it's a very imprecise science.
Brilliant. Okay, I think we'll cut it there. Thanks very much, Tom. Let's make a round of applause for Tom. Just a couple of little things. A few people have been asking me tonight about presentations and how they get involved, and we are looking at how we can get everyone involved, how we can actually change things about a little bit. And so we've had a strategy meeting this afternoon, and so watch this space. If anyone's interested, just reach out, and you can reach out to Emily at inquiries@hcaa.org.au, and we'll take those on board. Also, can I ask Rod Weir and Rod Jackson to step aside? And just got a picture over there in a second. I was going to say something else and I forgot. Okay, so can we just say, we'll big round of applause to all our guests and all our presenters tonight who do this out of their own time, and let's give a little respect to them. So a big round of applause to everybody who's present. Alrighty, so Derek and Alfie's here. Maybe Derek wants to say a word. Do you want to say anything, Derek? Yeah. Derek's from Adelaide. What's happening in Adelaide, Derek?
Well, actually, we're going to be also talking about the grease arrestor standards that's coming up. We've actually got SA Water, which is our state authority. They're going to talk about the trade waste. They're probably going to not provide too many good points. They're not very happy with the new proposed standards. So we've already provided a lot of our comments on that standard. So I'm sure you'll see them, Kate, very soon. And we've been talking a lot also about the problem with the bacteria in the water at the moment, with Legionella, and the temperature controls aren't working. So it's good to see that at the moment that New South Wales have got similar subjects at the same time. So we provide exactly the same presentation here, what you do here as well. So it's nice to see different people and meet some new people. Hopefully we can see some after some drinks as well. Would be great. So thank you.
Thank you guys for coming on Saturday and to Alfie too. So just the last 2 points. So the next meeting is in Hobart on the 20th of July. So I don't know if anyone's traveling down that way or any affiliates going down there, but it's on the 20th of July and Ryan's online. I'm sure we'd love to see you there. And finally, Canberra is on the 27th of September. So the last thing I was going to say was, can I just ask all the HCAA committee members to stand up wherever you are. Is Matt gone? So I just wanted to say that we've had a meeting this afternoon, and so we're looking at different, like I said before, strategies and how we can improve things. And so you can see the team here. There's actually more, they're not all here. However, if you've got any suggestions or if there's anything that's like sort of, I wish they were doing this please reach out to one of these people here after the drinks once we finish. I'm sure they'd love to hear it and feedback to you. So yes, so we're going to wrap up now, and make sure you talk to one of these people, and we're your voice, so we need to hear what your feedback is. We appreciate it. So thank you. You can sit down. Sorry. Okay, and once again, thank you again for all affiliates and our supporters. We can't do without you. Oh, I've got a question. Have you got a statement? Hang on, I'm running towards you.
So I just wanted to remind everyone that the Backflow Prevention Association has got their conference on in Canberra on the 17th and 18th of August, if anyone's interested. There's websites up, you can have a look. It's at BPAA, and if you're interested, everyone's welcome to come along. Obviously a cost involved, but there's some interesting information there and a few good presenters. I think Howard's going down to make a presentation, so that'll be interesting. And I'd like to see a few people there if anyone wants to come along. Thank you.
Thank you. The last thing I was going to say, I just remembered, was when you register for this event, obviously you get the CPD points. However, doesn't mean that you register, you get CPD points. So if you come, you'll get them, but if you don't come, you won't get them. So please spread the word, let your colleagues know, because we pay for extra seats, extra dinners, and extra drinks. So it's really important. So if you can let everyone know that, that'd be great. It's a little bit of a bugbear for the committee, and so we have to pay money. And it's your money, we're spending your money. So yeah, just finish that note. Alrighty, that's the last slide. The meeting is closed. So please mingle and enjoy. Thank you.